Hello students, welcome back to my channel Concept Tech 2018. I am Dr. Sunanda Manke and this video is a part of series on online electronics laboratory, and in this part we'll discuss the lab exercises on analog to digital and digital to analog converter circuits. This is the list of experiments which will be performed in this part. We have one experiment on analog to digital conversion using flash converter. Then two experiments are on digital to analog conversion, weighted binary method and R-2R ladder network method. The last experiment is on binary code conversion and it will be performed in virtual lab. This is the experimental setup which will be used to perform a to D and D to A conversion experiments. This is the trainer kit, and outer one is the general purpose kit on which this trainer kit is mounted. The DC supply to this trainer kit is provided by these knobs given here. Then we have input switches here. Digital input is given through these switches, and you can observe here these switches are having two positions, high and low. So we can change the position of the switches and accordingly we can apply 0 or 1 input to the D2A converter circuit. So digital input is provided using these switches. Then we have this variable analog input knob. With the help of this knob, analog input can be varied and it can be connected using these 2 points here. And this is the voltmeter which is used to display the voltage, analog voltage here. So when we are converting analog signal to digital signal, the input is given by this knob and the output is observed on the LEDs which are available here, or even they are available in the kit as well. And when we are doing the experiment on digital to analog conversion, the digital input will be given through these switches and analog output is measured on this meter. Although this acts as both voltmeter and ammeter, but we are going to use it as a voltmeter. This is the trainer kit on which experiments will be performed. You can observe here we have a flash A to D converter, 3-bit converter here. Then we have this weighted binary D2A converter here and R2R D2A converter is here. So these three experiments will be performed using this trainer kit. Assignment 3 is again a digital to analog converter circuit. The network which is used or the circuit which is used for conversion is R-2R ladder network. You can observe here R-2R ladder network where R value is 1K and 2R value is 2K. This B1, B2, B3 and B4, these are the input digits, right? It has high value and low value. So when the switch is at this position, it is giving 0 input, and when the switch is changed to another position, it gives 1 input. Thus these switches apply 0 or 1 input to this circuit. This is the complete network, right? And the input is applied at the other end of the 2R value, that is 2K resistor. And the output voltage is observed on this pin. It is connected to the voltmeter, and the voltmeter measures the voltage available here for different combinations of the input switches. Let's do this experiment. Let's do the experiment for R2R ladder network. You can see the 4 switches here, B0, B1, B2, B3. All are at 0 position and the value is 0.0. Now we'll increase it to 0.001, makes it 0.2 volts. 0.010, 0.4 volts. 0.011, 0.6 volts. 0.100, 0.8 volts. 0.101, 1 volt. 0.110, 1.2. 0.111, 3 ones here you can observe. 1.4. Now 1,000, 1.5. 1,001. 1,001 gives us 1.8 volts. 1,010. 1.9. 1011. 2.2. 1100. 2.3. 1101. 2.6. 1110. 2.7 and 1111 gives us a value of 3 or 2.9. There is some error, right? So 111, that is highest value, is 3 volts here, which is varying between 2.9 and 3. Now we are reducing the value with the help of the switches. You can see here all the switches are at 0 position and the value is 0 volts. This is how this circuit works. We have observed in this experiment that as the values of the input bits is changed, the output changes. We are giving 4-bit input here and we are observing the output voltage on the voltmeter, and we have seen that for the lowest value of the input, output is 0 volts, and for the highest value of the input, output is 3 volts. I have written two values here, 1.5, 1.6, 2.7, 2.8 here. It is because of some calibration error in the meter or some error due to tolerance in resistors in the given circuit, and thus this circuit is working as a 4-bit digital to analog converter circuit. I hope you have understood the working of R2R ladder network here. Thank you.